Okay, so we're talking about arithmetic sequences in series, which basically is just your arithmetic progression of numbers. We're trying to figure out what the formula is going to be. I thought you had to do a little bit more figuring in your head to figure out what the formula is going to be, but there's actually a really nice formula that works every single time, as long as you know what the first term is and you know what the difference is between your first two terms or any two terms in your sequence, okay? Our fixed number that it says is our that's added every single time is our common difference. So we're going to label that with a D. Okay, so our common difference D is that notation there just means we're taking one term, a sub n plus 1, and we're subtracting the previous term. It could also be like a sub n minus a sub n minus 1. It's just taking and subtracting two terms from each other. If we're trying to find some n value, some n term, we're going to use this formula. A sub n is equal to a sub 1 plus n minus 1 times the difference, where a sub 1 is our first term, okay? The first term in whatever sequence we're given. So we're going to use those two formulas on this page here. First one's pretty easy. It says find the common difference D of the arithmetic sequence here. What is happening from each term?
2.
Plus 2 every single time, right? So our common difference is 2. Now, I could use this fancy formula up here, but I don't think we really need to, especially if we're given these like written out like this. Otherwise, technically, you could do like -7 minus a -9, which gives you 2. But if you see what pattern's happening here, and you're given that pattern, I would just use that instead. Now, the next part here says to find the first 5 terms of the arithmetic sequence. Okay, it's just written a little bit different than it was last time. So instead of given like an a sub n equals n plus 5 and plug in your values from 1 to 5, it's going to tell you for this one, like the first term is 7. The common difference is 3. So I know my first term, a sub 1, is 7. A sub 2 would be 3 less than that, so that'd be 4. A sub 1 would be 1. 4 minus 3. A sub, oh, no wonder you looked at me like I'm crazy. It's because it's a sub 3. A sub 3 would be 1. A sub 4, subtract 3 would be -2. And what is a sub 5 going to give me? -5. Okay, so no algebra yet, just finding the first terms. Next one here is written a little bit different. It says a sub 1 equals -12, so that's my first term. And then D equals 5, meaning my difference is 5. So I'm adding 5 each time because it doesn't say minus. So what is a sub 2? -12 plus 5, 7, -7. A sub 3, -7 plus 5 would give me -2. -2 plus 5 gives me 3. And 3 plus 5 gives me 8.
So basically, if these are positive, you add these negatives.
Exactly. Now, there might be a crazy one on your homework that's like, let's say my first term is x plus 3y, and my second term is 2x minus 4y. How do I get from one term to the other? What am I adding? I'm adding an x, but I'm subtracting 7y. So that's your common difference between those two terms. Okay, so now is when we're going to have to actually use the formulas. Okay, it says find a sub 13 and a sub n for the arithmetic sequence here, and we're given the first 4 terms there. Okay, so I know 2 things. I know my a sub 1, and I know the difference. What is my a sub 1? -3. It's my first term in the sequence there. My difference, what's happening every single time I move up to a number? I'm adding 4, okay? So my difference is 4. Okay, so up above we've got 2 formulas. If we're trying to find a sub 13 and a sub n, the formula that we're going to want to use is which one? The red one there or the blue one? The blue, because I already know what my difference is, right? So I'm going to use that blue formula up there. And I'm going to write a, oh, that was way large. A sub n is equal to a sub 1 plus n minus 1 times my difference. So let's go ahead and plug those values in. We know what some of those values are, right? So a sub n is equal to my a sub 1, which is negative 3, plus n minus 1 times my difference. What's my difference? 4. Okay, that's my general formula for this sequence. Now, we could clean that up a little bit, right? Make it a little nicer. Distribute that 4. I get negative 3 plus 4n minus 4, which would give me 4n minus 7. So that means if I want to figure out whatever term in my sequence, I could plug in 55 and find out the 55th term in the sequence by taking 4 times 55 minus 7. If I specifically want to find a 13, what am I going to plug in for n? 13. So I've got a sub 13 is equal to 4 times 13 minus 7. And now we can just go ahead and plug in our calculator. What is the 13th term of my series going to be, or my sequence? 45. Okay, see how those formulas are pretty helpful there? Okay, next one here, it says, we're just given a little bit more different information. Find a sub 18 and a sub n for the arithmetic sequence having a sub 2 equals 9 and a sub 3 equals 15. Okay, so what do I know given these two values? What does that tell me? My difference, right? My difference between these two from 9 to 15 would be 6. The other thing I need to know for that formula of a sub n, however, is what? The starting point, right? A sub 1. So a sub 1, how would I find that? Going backwards. Subtract 6. Subtract 6 from 9 and I get 3. And now that we know those two things, the problem is just the same as before, okay? So I'm going to use that formula again, and I'm going to say a sub n is equal to my a sub 1, which is 3, plus n minus 1 times my difference, which is 6. Let's just clean that up a little bit. I've got 3 plus 6n minus 6. Which means I'm going to have 6n minus 3. Okay, so that is my a sub n. And now I can figure out what my a sub 18 is. So I can just plug in 18 where n is. So I got 6 times 18 minus 3. Plug that in our calculator. What are we getting? 105. Okay, this is where it gets a little tricky, because if I look at my things that I'm given a sub 8 and I'm given a sub 16. It says to find a sub 1. So I don't know the difference and I don't know a sub 1, and that's the two things that like the formula relies on, right? So what are we going to do? We're going to write two equations because we're going to have two unknowns, and then we're going to be able to solve it, right? So I'm going to color code this. I'm going to have my a sub 8 equation be red, and I'm using that formula from up above. So a sub 8 is equal to a sub 1 plus a sub 1 plus, what do we got next? Our formula is n minus 1, so what's n in this case? N is 8, so 8 minus 1 times my difference. I don't know my difference. I don't know my a1. Don't we know what a sub 8 is? We know what a sub 8 is, yeah? So let's rewrite this as negative 16 equals a sub 1 plus 7d. Okay, now let's go do a sub 16. If I plug in 16, same formula, I get a sub 1 plus, my n value in this case is 16 minus 1 times my difference, which is d. But we know what a sub 16 is. A sub 16 is negative 40 is equal to a1 plus 17d. So now I have two equations, two unknowns.
Wouldn't it be 15?
Yes, it's 15. Thank you. And now I have two equations and two unknowns. So we can either solve this by elimination, or we could solve this with substitution. Which ones would you guys like to do? Elimination? We all good with that? What variable do we want to eliminate?
A sub 1.
A sub 1, because they both have a coefficient of 1, right? So let's go ahead and multiply this second equation by negative 1, and then I'm going to add it with that other equation over there in red. Okay, we could totally do substitution if you would rather. Either way is going to get you the same answer. Okay, so I'm going to have 40 equals negative 1 times a, so negative a sub 1, and negative 1 times 15d minus 15d. So now I can go ahead and add these two things together. Those a sub 1s are going to go away. And now I've got negative 8 times my common difference equals negative 16 plus 40, which is 24. And now I can just divide. So d is equal to negative 3. So now I know my common difference. But is that what I'm solving? No, I'm solving for a sub 1. So now from here, all I would have to do is plug in d to one of my equations and solve for a sub 1. So if I wanted to solve for a sub 1, I got negative 40 equals a sub 1 plus 15 times negative 3. So I got negative 40 equals a sub 1 minus 45, which means a1 is 5. Okay, so now we're going to find the sum of the first n terms of a sequence, okay? So like last time we talked about, when we were talking about summation, using that sigma, where you had something like this with some sort of a sub n sequence or whatever going on, okay? We're going to do that, but with a different formula that works a little bit quicker and a little bit more efficiently, if you ask me. So we're probably going to use this moving forward instead of the other way. And if you're using the other way with the sigmas, you're probably using a calculator, okay? So here's our two formulas. We're given s sub n is equal to n divided by 2 times, I want you guys to write on here, this is my first term in the sequence. We're going to find that sometimes maybe we're not starting, like if I had my sigma, most of the time it was I equals 1 on the bottom. Sometimes it's going to be like I equals 3. So like the first term is going to start with a 3 plugging in, okay? This a sub n is my last term. The last term in my sequence that I'm adding together. That s denotes like the sum of your total terms. And then this one, this first formula we're going to use if we know the first and the last term. Mostly just if we know the last term. Okay, if we don't know the last term, we're going to use the second formula, because all you need for the second formula is your first term, which is a sub 1, and your d, which is your difference. Okay? So we're evaluating the sum of the first 12 terms in the sequence. That's what s sub 12 means. It's not a sub 12, meaning the 12th term in the sequence. It's adding the first 12 terms of the sequence negative 9, negative 5, negative 1, 3, 7. So which one do you think we're going to use? Second formula. Because I know the first term, And I can figure out that difference pretty easily, right? So a sub 1 is negative 9. My difference between them is positive 4. Okay, so let's plug this stuff in here. So I've got s sub 12 is equal to 12 divided by 2 times, I'm just following the formula up there, 2 times a sub 1, which is negative 9, plus, what is my n in this case? 12, so 12 minus 1, times my difference, which is 4. Now, if you wrote that down, from here you could just plug the rest of that into our calculator. Unless you wanted to simplify it a little bit by hand first. I would just plug this straight into your calculator, and you should end up getting that your summation for the first 12 is equal to, let's see, I got 156. So adding all those terms together, we get positive 156. Okay, this next one says use a formula for s sub n to evaluate the sum of the first 60 positive integers. So what's the first positive integer? 1, 2, 3, all the way up to what's going to be my 60th positive integer? 60, right? So since I know my first term and I know my last term, which formula would be easier to use this time? The first one. It's a little bit shorter. It's a little bit easier. So I'm going to find s sub 60 is going to be equal to n divided by 2, so 60 divided by 2, times a sub 1, which is 1, plus a sub 60, which is 60 in this case. Now, this formula should look pretty similar to this formula that we talked about last class. Because if I just plugged in 1 through 60 here, I'm going to get the exact same formula as I get over here, right? Because n is 60, n plus 1 is 61. Divide that by 2, and we should end up with 1,830 for the sum of the first 60 integers. This one says the sum of the first 17 terms of the arithmetic sequence is equal to 187. We're given a sub 17. We're trying to find a1 and d. So, let's think about this. A17 is important because why? If I want to find the sum of the first 17 terms, it's the last one, right? This is the last term in my sequence. So I know my last term, but I don't know a sub 1 and I don't know d. So if I'm looking back up here at my formulas, which one do you think you're going to use? If I use the second one, I don't know a sub 1 and I don't know d. So I can't do the second one. I'm going to have to use the first one, okay? Because I know what the sum is, right? So our formula is s sub n is equal to n divided by 2 times a sub 1 plus a sub n. It says the sum of the first 17 terms, so n is going to be 17, but that sum is going to be 187. So s sub n is 187. So I can replace that. And then I've got 17 divided by 2 times, I don't know a1, but what is a17? Negative, was it 12? 13, negative 13. So last term in the sequence, a sub 17 is negative 13. So now from here, I just got to do a little bit of algebra. I would get rid of that 17 halves first if it was me. So I would times by 2/17, or make it a decimal and divide by the decimal. But when you do that, either way, what do we get on the left-hand side? 22 is equal to a sub 1 minus 13. So solve for a sub 1, add 13 to both sides, and I get 35. So my first term is 35, my 17th term is negative 13. Obviously the difference here is it going to have to be positive or negative to get that negative if I start at A1 is 35 and A17 is negative 13. So now I have to find my difference value, which means I'm going to have to use which formula? The second formula, okay? So again, your formula is S sub n is equal to n over 2 times 2A1 plus n minus 1 times d. Now I can plug all the things in that I know. I know that S sub 17 is 187. What is my n going to be? 17. Now I know what 2a is, or sorry, a to the a sub 1, that's 35. And then my n again is 17, so 17 minus 1 times my difference. I don't know what my difference is yet. I'm going to multiply both sides here by 2/17, which is what we just did, so we should remember that one. Gave us 22 is equal to 70 plus 16d. Nice little two-step equation here. Subtract 70 and divide by 16. What do you find for your common difference? Negative 3. So look at what you're given, decide which formula you're going to use, and then solve for that missing variable. Okay? Now, I'm going to show you guys how to do these last two problems, both by hand with this summation formula, not using the properties that we talked about last class, but using the summation formula. But I want you to plug them into your calculator first. Okay, so try plugging in A and B into your calculator, and I will tell you, you should get, on your calculator, 300 and negative 98. But click math, option 0, and then plug in all of these things and check to make sure you can get those two answers. We could use the properties that we talked about last time, like how do I move the 4 out, how do I can do 10 times 8 and get the 80 and then add that with the other stuff, but we can also just do this using our summation formula of S sub n is equal to n over 2 times a sub 1 plus a sub n. Okay, we just have to pick out that information from our sigma here in order to solve it. What is my n in this case? How many terms do I have? I have 10 terms, right? So S sub 10 is equal to 10 divided by 2 times, now what is a sub 1? I'm not given it, but could I find it? Yeah. So a sub 1, all you would do is plug in 1 where you see I, right? So I've got 4 times 1 plus 8 is equal to 12. So I get 12 up here for my a sub 1. And now what is my a sub n, or my a sub 10 going to be? What do I have to do for that? Plug it in as well. So I'd have 4 times 10 plus 8 would give me 48. So if I put 48 up here, and then I evaluate that on my calculator, do we end up with getting the same answer of 300? Yeah. That's kind of how you can do it by hand using the formula. But again, if you were given it, like this on a quiz or a test, you can plug it in the calculator as long as you are real confident with your calculator skills. Okay? Now, this next one's a little different because it doesn't start at 1. So we need to think a little bit more kind of critically about this one here. What term am I starting on here? The third term, okay? I'm starting at 3, plugging in 3, and I'm going up to 9, right? So I have a term a sub 3, I have a sub 4, a sub 5, 6, 7, 8, and 9. How many terms do I have there? 7, right? So I have 7 terms. I'm only adding 7 terms together. I'm not adding 9 terms together. So my n is actually going to be 7 in this case. So I'm going to use that same formula. S sub n is equal to n over 2 times a sub 1 plus a sub n. This is where the a sub 1 and a sub n notation is a little kind of confusing because do I have an a sub 1? Is that my first term in this sequence? No, I have an a sub 3, right? But this is still the first term in my sequence, so that's actually what's going to go here. My last term in the sequence is a sub 9. That will still be my a sub n, even though in this case n is actually not 9, it is 7. Does that make sense? Because we have to account for those other 2 that we're taking away since we're not starting at 1. So I'm going to find my summation of those 7 terms by taking 7 divided by 2. And now I need to figure out what is actually a sub 3. Plug in 3. I get 4 minus 3 times 3, which would give me negative 5. So I've got negative 5 in parentheses here. And then a sub n or a sub 9 would be 4 minus 3 times 9. And that would give me negative 23. So if we plug that into our calculator, we should end up getting negative 98 as well. All right. That is it for the arithmetic sequences. You guys got a good chunk of time here. Go ahead, give you a